Okay. Today, inshallah, we're going to talk about the covalent bond. The covalent bond. So I'm trying to open it. Okay. Do you hear me, guys? Because I'm working through the internet.
Yes, sir.
Yes, that's very good. I want to share. Do you see my screen right now or not? I'm sharing my screen with you.
Yes.
Okay, but I want to share the audio. It does not appear to me sharing the audio. I'll try to play a video. I want to you tell me if you hear it or not. There's a sound. You hear the sound here?
Non-metals
Yes.
are found on the right side.
Yes, here's the voice. That's very good. So today, inshallah, we are going to talk about the second type of bonding, which is covalent bond. Before I start with this one, let's recap on the previous one. On the chat area, please tell me what is the ionic bond that we talked about in the previous session. So in the chat area, I want to see your answers about the ionic bond. What is ionic bond? I'll send a message to see if you're receiving my messages. Do you receiving this one? Do you see this one in the chat? Hi, I said hi. You receiving that, guys?
No, sir.
Okay. Okay, that's another one, I think. Okay. That's it. So Muad answering here. I open the chat right now. I say hi. You receive this one right now? The chat area? Must type?
Yes, sir, we hear you.
We have it here.
Oh, the
Okay.
message.
That's okay. Abdelhadi said elements that don't have complete sets of valence electrons. Complete sets of valence electron tend to react. That's very good.
Abdullah, Mr.
Abdullah. Okay. Abdullah Abdul Baqi. Muhammad Al Abdul Baqi said the Abdullah Dahilan. Okay. I don't see the full name. Muhammad Abdul Baqi said the exchange of electrons between a metal and a non-metal to make an element stable. That's very good. That's ionic bond. And Muaz said when the electron is transferred from one electron to another to be stable. This is ionic bond. This is very good. When the electron is transferred from one electron to another to be stable. You say it again, Muaz. Okay, guys. So this is ionic bond. So this is Abdullah Dahilan. What did he write here is very important, because elements that don't have complete sets of valence electrons in the outermost shell tend to react. Let's see a video about the new type of bonding, which is called covalent bond. Covalent bond.
Covalent bonds. In this video, you are going to learn about covalent bonds, how they are made, and how they form. If you haven't seen it already, first have a look at our video, Structure and Bonding. Only the noble gases exist naturally as single atoms. All the other elements of the periodic table
So all the noble gases exist as single atoms in the nature. Noble gases, I mean the last group here that's not appeared here, which is helium, neon, argon, krypton, and so on. This is the last one after this group, halogens. So they didn't put it here right now. So this is called noble gases. Again, noble gases, the last group in the periodic table, they exist naturally as a single atoms because their outermost shell is filled with electrons. So they don't want to get into any type of reactions because they already have a valence shell that is stable, filled with electrons. All other elements will exist as compound and compound. All other elements in the periodic table, you'll find them as compounds. Let's continue.
Have partially filled valence shells or outer electron shells. Atoms bond by swapping or sharing electrons in their outer shells.
If you count this one, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and this is 7. This is alone. It needs another one. Okay, this is fluorine. So it will have it by gaining electron from an atom of metal and will form ionic bond, or by sharing. And this is our lesson today, sharing electrons. Let's see how this will happen.
When very different atoms react, like metals and non-metals, they normally swap electrons.
So when two very different or far different elements react, like metal and the non-metal, this is metal sodium and non-metal fluorine, they will transfer or swap electron. One of them will lose one electron, and the metal, when they lose electrons, they lose valence shell. They lose a shell too by losing the outermost electron. So it will lose one electron, will gain by fluorine. This will be negative ion, anion. This will be positive ion, cation, and the attraction force between the opposite ions will form ionic bond, an ionic bond.
This is ionic bonding. But when similar atoms react, like non-metals combining with other non-metals, they share electrons. This is covalent bond.
So when fluorine react with each other, like non-metal with non-metal, they will share electrons. Like this one. So this electron, this one fluorine atom, and this one is another fluorine atom. So this one needs one, and this one needs one. So they will go to each other and share. So these two electrons will be shared between two different nuclei, this atom and this atom. So they will revolve here for some time, and they revolve in about the other one for the rest of the time. So they will divide their time, those two electrons, the shared electrons, they will divide their time between two different atoms, or the atoms that are making a covalent bond.
Non-metals are found on the right-hand side and upper.
So what we know right now, that sharing or covalent bond occurs between non-metals and non-metals. But ionic bond happens between metals in the left side and non-metals in the right side. Okay, guys? In the ionic bond, they transfer electron from a metal to non-metal. In the covalent bond, they are sharing. So covalent bond occurs between non-metals and non-metals. These are non-metals. Hydrogen, this is number one, and all of these are non-metals. The type of bond that they are making when they react with each other is called covalent bond, by sharing, not losing.
Part of the periodic table. Some common non-metals are carbon, nitrogen, oxygen, and the halides. They have shells of electrons that are normally half or more than half full of electrons. Since they have a strong attraction for a few additional electrons, it is energetically unfavorable for them to lose electrons, so they share electrons by overlapping orbitals. This makes a bonding orbital, or covalent bond, that contains two electrons. If there is space in the outer shell, a non-metal atom can form double or triple bonds, like in oxygen or nitrogen. In the displayed formula of a compound, we represent a covalent bond with a straight line.
So he mentioned the types of covalent bond. In the covalent bond, we have three types. I'll talk to them separately but generally he mentions them here. We have 3 types of covalent bond. Number 1, single covalent bond. Number 2, double covalent bond. And number 3 is triple covalent bond. We will present all of them right now. In a while, we will represent them. But this is initially are the 3 types of covalent bond: single covalent bond, double covalent bond, and triple covalent bond. They are the covalent bond represented by a dash, as you see right now. The covalent bond between hydrogen and the chlorine is represented by a single dash between hydrogen and the chlorine.
Like this. We can also represent a covalent bond as a dot and cross diagram. These diagrams show only the valence electrons. To learn more about dot and cross diagrams, watch our video on dot and cross diagrams.
Dot diagram, we took it previously in the previous lesson, when we represent the atom, all the atom with a symbol, and the valence electron we represented by dots. This is called dot diagram. We take it.
Covalent bonds are directional, which means they are in a fixed position, like holding hands. This is different from ionic bonds, which are formed with an electrostatic attraction between charged ions. The overlap between orbitals means that
here, in the covalent bond, the atoms overlap. They fuse with each other, and partially, not completely. They fuse partially. As you see, this atom are fused partially with each other, so they are overlapping. In the covalent bond, the orbitals itself, the atom itself, will overlap, will interact with each other, will fuse a little bit, partially fuse with the other atom.
The atoms in covalent bonds are very close. These things make covalent bonds strong. There are 2 kinds of covalent structure: small molecules, like water, and giant compounds, like diamond. Because the electrons in the bonds are evenly shared, bonds are not polarized. There is little attraction between molecules, and forces between molecules are weak.
So between molecules, this is covalent molecule, and this covalent molecules, for example, this is a fluorine molecule and this fluorine molecule. So they are not polarized. They don't have an overall charge, all of them. So the attraction between molecules is weak. Weak forces between molecules. So all of them exist in the normal, in the at temperature room, at room temperature, as gases. They exist at room temperature as gases.
Compounds made from small covalent molecules have low melting and boiling points, and
the melting and boiling point are so low because between molecules the attraction force is so weak.
Volatile. They also don't conduct electricity.
And they don't have free ions or free electrons, so they don't conduct electricity. So low melting point because they don't have a strong attraction force between molecules, and also low boiling point because they don't have strong attraction force between molecules. And beside this, they are not conducting electricity because they don't have free ions or free electrons to conduct electricity.
Carbon and silicon tend to form giant covalent compounds. These bond in the same way, but instead of forming small molecules with 1 or 2 bonds, they form 4, making up huge lattices or chains.
So that's enough for now in this video. Let's go back to the covalent bond. We'll start reading from here. I want to start first to show you the types of covalent bond. Let me represent it for you. But it will appear from this one. Okay. Pick someone randomly. Abdullah Mubarak. Abdullah Mubarak. Abdullah.
Yes, Mister.
Okay, Abdullah, I want you to start read, please, this part. Read it.
Of many, many linked up atoms.
I read that.
Yes, it is.
Plants absorb water through the roots from soil or from a solution containing nutrients. Carbon dioxide from the air enter the plant through small openings in their leaves. The plants use the energy from the sunlight to convert water and carbon dioxide into sugar.
All of these compounds mentioned here are covalent compound. Water, covalent compound. Carbon dioxide, covalent compound. Or have covalent bond. Sugar also have covalent bond. All of these are covalent compounds. That's the meaning of this. Thank you, Abdullah. Let's maybe someone else because we have a lot of students to answer it. Adam is here. Adam in the chat. Adam. Ahmed Muttab al-Gannas.
Yes.
Ahmed Muttab. Okay,
Yes.
Ahmed. Read this part, Ahmed.
How are atoms held together in a covalent bond?
Bond, yeah.
The attractions between the shared electrons and the protons in each nucleus hold the atoms together in a covalent bond. A covalent bond is a chemical bond in which two atoms share a pair of valence electrons.
So he's mentioned here, thank you, Ahmed. He's mentioning here the source of the covalent bond. The attraction between the shared electrons, as we see right now in fluorine, for example, and the protons in each nucleus hold in each nucleus of the two atoms that are sharing, hold the atoms together in a covalent bond. Yes, let's take this as an example. Another example. So let's take hydrogen as an example. Let's see. Let me share with you this to show you what does it mean here. So these are hydrogen atoms, as you see. These are the shared electrons. Okay, shared electrons revolve around the nucleus of this hydrogen. They will revolve around this nucleus and around this nucleus. You know that electrons has a negative charge, while the nucleus here of this one has a positive charge, and the nucleus of this one has a positive charge. So these electrons will revolve, as you see, in this direction, sometime around this one, and sometimes around this one. They revolve here and in this direction. Okay, guys? So they will continue to revolve around this nucleus here and this nucleus here. They will spend half of their lifetime around one nucleus and the other half around the other nucleus. The attraction force between the negative electrons that revolve around the two nuclei and the positive nucleus here and the positive nucleus, this attraction force will form a strong or the covalent bond, a covalent bond. So this is the source of covalent bond, the attraction force between the negative electron that revolve around the two nuclei and the nuclei of the two shared atoms. So this will create the covalent bond. Thank you, Ahmed. And let's go عبد الهادي. عبد الهادي. عبد الهادي. Okay, and I called Adham. He didn't answer me. He didn't type in the chat. And Faisal. Faisal Mahesh.
Yes.
Okay, Faisal, I want you to read this one, the slide.
Okay. Covalent bonds sharing electrons. The hydrogen atom has one electron. If it had two electrons, it would have the same electron configuration as a helium atom. Two hydrogen atoms can achieve a stable electron configuration by sharing their electrons and forming a covalent bond. Two atoms share one pair of electrons. The bond is called a single.
A single bond. So here he's talking about the first type of covalent bond, which is the single bond. And let me explain it to you here. And he mentioned hydrogen as example. This is the example of hydrogen and how we represent it. Let me just draw it for you so I can explain it. So we have hydrogen. I will draw the first hydrogen here in blue. We have the hydrogen nucleus. It has one proton. It has one proton. So this is the nucleus, and it has one energy level. So this is the first hydrogen atom, and this is the second hydrogen atom here. Okay. We have in this one proton, only one proton. This is the first hydrogen atom, you guys, and this have only one proton inside it, and this one has only one electron, and this one has only one electron. I make a difference so you can understand what's happening. So what will happen? This one is not stable because the outermost shell, this is the outermost shell, the first shell. This is the nucleus. Let me make the nucleus in red so you don't confuse. This is the nucleus, and this is the nucleus. Okay? It has only one shell, and one electron. So hydrogen here will search for what? Will search for having another electron by gaining or sharing. What will happen that these two electrons will come close to each other and will share their valence electrons as follows. So this one will completely move here, and this one will completely move here, and they will come closer to each other. This is the first step. Okay. Like this. And the two atoms will be shared here. One is here, and the other one is here. And this would be the two nuclei that would come to the middle two, because this one will come here. That's it. So they will come closer to each other, as you see right now. To make a covalent bond, the atoms must come in contact. They must overlap. They must partially fuse. They contact with each other. Right now, we have hydrogen make a covalent bond with another hydrogen by each one shared one electron. This one shared one electron, and the other one shared one electron. And these two electrons will revolve around the first hydrogen atom and around the second hydrogen atom. They will spend half of their lifetime around the first nuclei and the other half around the other nuclei. So the attraction between the negative electrons and the positive nuclei will form the covalent bond. This one, we call it a single covalent bond because each hydrogen atom shared by one electron. Make the other one another color. So this hydrogen shared by one electron, and this one shared another electron for itself. So we call it single covalent bond. A single covalent bond arises when two atoms, every one of them shares one electron. So the first hydrogen shared one electron, the second hydrogen shared one electron. This is the first way to represent them by the orbitals. The second way, I can represent single covalent bond by a dash like this dash. So this is single covalent bond. We represent it like this. Or the other ways to present a covalent bond, as you see here. The first one, electron dot diagram. I will represent the covalent bond by dots. The same one, I will write dots. The first one here. So another way to represent the covalent bond by dot. First. So this is the first way to type the symbol of the atom and then represent the dots for the shared electrons, as you see here. So I type the symbol of hydrogen atom, the symbol of the second hydrogen atom, and I represent it by two dots, one from the first atom and the second one from the second atom. This is called electron dot diagram. We'll see more examples about it. Structural formula by representing a dash. I will not representing dots for electrons. I will represent single covalent bond by a dash. Okay, guys? The third way, by drawing the space filling model. This is called space filling model. This one show how the orbitals are overlapping. So this is called space filling model. The last one is called electron cloud model. This one represents electron cloud. So we have four ways, as you see, four ways to represent the covalent bond. The first way, electron dot diagram. Second way, structural formula. Third way is called space filled model. The last one is called electron cloud model. All of them are representing the same thing, which is called the covalent bond. The covalent bond. This one only single one because it's a single covalent bond. After a while, we'll take double covalent and the triple covalent bond. And Ibrahim Anwar. Ibrahim Anwar.
Yes.
Ibrahim, I want you to read this one.
Covalent bond. There are several ways to show a covalent bond. The electron dot.
Covalent bond.
Covalent bond. In the electron dot model, the bond is shown by the pair of dots in the space between the symbols for the hydrogen atoms. In the structural formula, the pair of dots is replaced by a line. The electron cloud and the space filling models show that orbitals of atoms overlap when a covalent bonds form.
Yes, the electron cloud and the space filling model show the orbitals of atoms overlap when a covalent bond forms. So this is different types of sharing covalent bond. Molecules of elements. Let me pick someone to read it. And Muammal. Muammal is here. طيب محمد العبد الباقي. محمد العبد الباقي. Muhammad, I want you to read this slide, please.
Covalent bonds, molecules of elements. Two hydrogen atoms bonded together form a unit called a molecule. A molecule is a neutral group of atoms that are joined together by one or more covalent bonds.
So this is a molecule, is a neutral group of atoms that are joined together by one or more covalent bond. This is called a molecule, like hydrogen molecule. This one and the previous one, this is called the hydrogen molecule. Two atom covalent bond is called a molecule, and we call it molecular model. So the word molecule, guys, are not called for the ionic. I can say sodium chloride molecule. It's called sodium chloride compound. You see the difference? So in the ionic bond, we call it compound, ionic compound. But here we call it a molecule. So the word molecule is only for exclusive for the covalent bond compounds, okay, or the covalent bond, the atoms that are bonded with covalent bond. So a molecule is a natural group of atoms that are joined together by one or more covalent bonds. Let's see another one. Thank you, Muhammad. And Murtada.
Yes, Mister.
I want you to read this one, please.
Covalent bonds. The hydrogen molecules is natural because it contains 2 protons, 1 for each atom, and 2 electrons, 1 for each atom. Chemical formula can be used to describe the molecules of an element as well as a compound. The element hydrogen has the chemical formula H2.
Yes, the element hydrogen, and this is molecule. Element hydrogen exists as a molecule, has the formula H2. Let me just type it for you again. Yes, that's it. So hydrogen here, I can represent it like this. We have H, and we have 2 atoms that are bonding, as you see, 2 atoms. So we call it H2. This is chemical formula for an element, molecular element, hydrogen. And we have the same for oxygen. We will present oxygen later. Okay, guys? And we have the same for chlorine, Cl2. All of these are called chemical formula for elements. And we have chemical formula for a molecule that's not element, molecule of a compound, like this, HCl. The bond between the Cl, the bond between the chlorine and the hydrogen is covalent bond. So this one is called molecule, but it's molecule of a compound. This is molecule of a compound. This is called molecule of an element. So the molecule of element from the same type. This is molecule of hydrogen element, molecule of oxygen element, molecule of chlorine element, and this is molecule of hydrogen chloride. Hydrogen chloride. So the word molecule is specifically for the molecule with or the atom that are covalently bonded, like all of these. And we call it element when they are the same type. We call it compound when they have different types. So this is molecule of element, molecule of element, molecule of element, and this is called a molecule of a compound. And also CO2, a molecule, because it's a covalent bond of a compound. We'll talk about this, all of this separately, guys. And H2O, a molecular compound or a molecule of a compound. Okay, guys? So molecule of element, when they are the same type, molecular compound, when they are different types, but all of them are covalent. But when I say NaCl, I can't say molecule because this is not covalent bond. This is ionic bond. I call it ionic compound. So this is molecular compound because it's a covalent molecular compound. Molecular compound. This is ionic compound. So the naming is very different here. Molecular element, molecular compound, ionic compound. Okay, guys? And the compound in the ionic form, on the ionic ion, we never say molecule. We say it ionic compound. We say it what? Ionic compound. It doesn't have the term molecule. So the term molecule is exclusively for the elements and compounds of covalent bond. But if we have ionic bond, we call it molecular. We call it ionic compound. Ionic compound. We will stop here today, guys. And right now, I will share with you an exam about covalent bonds. So bear with me for a few minutes.
Quizzes, Mister.
That's quizzes. I'll share with you only 10 is enough. So I will share with you right now. Only 10 questions to do them. So this is the link. I will send you there the link. So this is the link for quizzes. And that is the pen. So join please quickly, guys. It's only 10 questions.
Teacher, it says
Yes.
show me and I don't see any picture.
It says what?
What type of bond is shown in this image and there is no image?
What type of bond shown in this image? Yes, this picture in front of you, you can see it right now, this one.
No, there is another one.
This one, hydrogen.
Okay, yes.
This one.
Mr. Did you take the absence?
Yes, I'm taking the absence. I don't take for all students, I take for partial type of student, not all students. You're here, Muhammad. Okay. Okay, thank you for listening, guys. I will leave you with the quiz and I will end the session. So finish the quiz and I will
Thank
end
you,
the
teacher.
session. Thank you, guys.
Bye.
Mr.
Yes.
مؤمل
Yes.